Okay, let's work this problem where we're given information about a person and their shadow and the length of a tree's shadow, and we want to find the height of the tree. So we want to find this distance h right here. And what I've done is I've drawn a picture that will help me visualize what's going on, and by doing so, hopefully you can see that we have some similar triangles. We have the height of the person right here, and their shadow is going to be similar to the height of the tree right here and its shadow. So the first part of this problem is simply setting up that ratio. So we'll say h over 54 feet is equal to, now you got to be careful with the units, the corresponding side is 5 feet and 11/12 inches, or feet, converting inches to feet. So that will be in units of feet. And its shadow here is 9 feet. Okay, so we can simply solve. These feet will cancel out. Our h will be in terms of feet, and we'll get an answer of 35.5 feet. So that part is pretty easy. Okay, the second part of this problem is a little more difficult because we don't have a direct sort of ratio to deal with, but let's think about what we do know. So I am going to, the problem says when the sun is in the morning, its sun rises at, we're given 6 a.m. here. So I'll draw the sun over here at 6 a.m. and it sets at 7 p.m. So let's draw 7 p.m. right there. So that's what we want to relate somehow to the sun being up here. Oops. Get the right tool here. At some point in time, causing this shadow right here. Alright. So the sun is going in a circular arc throughout the day, and we want to figure out how to relate its position up here at this point in time with our known values of sunrise and sunset. Well, we know at this point in time right here we have this angle. Okay, we've already calculated h, so we can easily find the value of that angle. And we want to find the time in minutes that's left in the day. So basically we want to find the time for the sun to go from here to here. Okay, so drawing it in this way sort of leads us into being able to see that the angle traversed by the sun during that time is going to be related to our angle theta. So what do we know about the traversal of the sun? Well, we do also know that when it's up here directly above at noon, we can assume that's going to be half of our day, and so it's traversing half of a day in 90 degrees. Alright, and we know our angle given, so that's the key here to working the second part of this problem. So let's figure out what half of a day in terms of time is. Okay, if we start at if we start at 6 a.m. and end at 7 p.m., well, you could write it out formally, but you know going from 6 a.m. to 6 p.m. is 12 hours. So going from 6 a.m. to 7 p.m. is 13 hours. So half a day is 13 hours divided by 2. So that's our half a day. And it's going to traverse 90 degrees. And the question is, how much time does it take to traverse theta? Okay, so we have to go back and calculate theta to be the inverse tangent of h, which was 35.5 over 54. Okay, so if we take the inverse tangent of this value right there, that will get that into degrees. That's related to 90 degrees right there. And then our t on the top is related to our 13, half of 13 hours right there. All right. And so we'll get t on this one equal to 2.406 hours. The question asks for minutes, so we'll just multiply by 60 and get 144 minutes. Okay.